Did you guys remember what we learned from last week? Last week we learned the exponent, right? Okay, exponent. We have several rules here, right? Exponent. First, we know the exponent is made something like a description, something like x. They have multi-x. You can see here multi-x. We can rewrite it into x 4 power 4, right? So they have the same number, same thing, product of them. We can describe into like this exponent, like 10 times 10 times 10 times 10. This is equal 10,000, right? We also can write it into 10 power 4, right? So, okay, so if there is x n number, x n of x product of them, say x power n, right? So this is the exponent. So exponent have some calculations as well, right? When they do the product, that's x m n x and mx product. If they product together, so totally have m plus m together, right? They totally have m plus m cancel x product of them. So this is called product rule. Second, if they divide, when they divide, so top one have x, n cancel x, the bottom one m cancel x. So after factor of, so you can get this one, right? So when the n equal m, so here became what? N equal m, here's x power 0. N equal m, so means the top one and the bottom denominator one is the same. So they equal 1, right? Same number they divide, they will be equal 1, right? So, and we also power rule. So if the x times n, m equal n, this is x, we call n, xn, this is the same thing, right? Power square, right? So we can say x 2n, right? Because of this one is n plus n. This one is 2 times n. So x power n. So we go back here, say x n, if they power, we say x, we give another, say c, power c. So the result will be product of these two numbers, right? Right. Okay, so this is number 5. Number 4, power rule. Also, we learn the negative rule, right? Negative rule, say x n divided m. So we suppose x is equal 0. Here is m. You can see this one here it became 1, right? Divide x power m. Actually, here also you can say x power 0. So here it's 0 minus m. 0 minus m actually negative xm, right? X power negative m. So actually they can replace, we can rewrite it into xm power 1. Change this one into the denominator. So this is the number 5, right? There's several of them. So we need to use these kinds of rules in all exponent calculations. We also talk about a little bit more is number 6. If there's a 2 number inside the power, so each of the factor, this is 1 factor, 2 factor, right? Each of the factor power by itself, right? If there is fraction, a divided b, the power n, so it's just like each of the denominator and numerator power by itself, right? So you can see a 1, 2, 3, 4, 5, 6, 7 actually here. We need to learn from last week. All right, so let's use the homework to review what we learned from last week. All right, I clean the screen. So let's see the homework part. All right, take your homework out and check them. Make sure each of them is, the answer is close to what is the same as what we did, okay? Right, so let me go back here one more time. So here I have the 1, 2, 3, 4, 5, 6, 7 kinds of different power rule will be used again in our homework, right? All right, so let's see the homework. All right, so let's see the 43. 43 already given here, right? This is like a factor itself have their power by itself, right? They already give the homework, give the example answer here. All right, so see the 44. So this is two factor, each of the factor power by itself, right? Right, okay, the same here. Here actually have a little bit complicated, more complicated. So you can consider here 2 times a powers a 2 a power 5, right? So each of them by itself need a power by itself, right? So least power, a least powers of 3, right? So you can got here is this is 8. So what about this part? This part one more time. We used a power n power 5 and times 3, right? So a power 15, right? So you can got it here. So again, two separate part, right? All right. Let's see next. So this is the same. So here has 4, right? X power 6. Each of them will need power by itself, right? Here square here, and this one, right? Each of them power by itself, right? This factor and this factor, right? So here got a 16. What about the next one? So next one is x power 2 times 6, got a 12, right? All right. So let's see number 47. Let me write this way. So here is, we consider here as x squared y cubic, right? X squared y cubic. Each of them powered by 5, right? Powered by 5. So you got here, this one powered by 5, this one powered by 5, right? So, okay, so you got x, this part is 2 times 10, 2 times 5, got power 10. What about this part? Yes, 3 times 5, you got 15, right? So this is 147. Okay, let's see 48 here. So here we can consider 2 factor here, right? A power 4, B. Okay, so this part power by 7, right? And this part power by 7. So you can got A power 28, here 28, B power 7, right? All right. So see this part, you see 49. 49 here. 49 here. Let me zoom in a little bit, make sure you guys can see what I'm writing. Right, so I save the screen first and clean screen. Okay, so make sure you guys can see well. All right, 40. See this 49. See 49 here. Okay, so here, how many factors here? 1, 2, 3, 4. Right, 4 factors. This earlier here just only 2 factor, right? 2 factor, 2 factor, 2 factor. But here is more. It's 4 factors. The 4 factors itself will be powered by square. So you guys can do pretty quickly. So -7 square, so became 49, right? So a square power 2, so we can quickly get a power 4, right? b power 5 square, actually b power 10, right? c square. So we can just quickly get out the results quickly. We don't necessarily do 2 steps, right? Same here. Let's see 50. So 1 factor, 2 factor, 3 factor, 4 factor here, right? So each factor need a power cubic, power 3, right? So -3 cubic, so it'd be -27, right? So x here became 21. Y here just only 1, right? The 1 they didn't write out, so make sure they are not 0 here. It's 1, right? So 1 times 3, so I got 3. Z power 6, right? 2 times 3. 2 times 3. Okay, let's go next. What do we say about this one? If the internal here is a fraction, the denominator and numerator and denominator itself will be powered by itself, right? Right. So let's see. Same here. Denominator and numerator. Denominator here bottom, numerator top, itself powered by itself. What about this part? You can see the numerator power itself, denominator power itself. But this one we need to have 2 factors, right? So we need to put it inside. Make sure we go to the most simplified version, right? Same here. So x, y, itself square, so itself square, each of the factor square. The bottom part 7 square, so you got 49, right? Same here. The top part square. So if you move this one inside here is each of length square, right? And here square, right? So you can see this one would have became what? This part became 4, right? X square, Z square, Y power 10, right? Let's see 56. So top part. So if you move this inside, get rid of here. So here square, cubic, and here cubic, right? So top and bottom by itself. And the numerator part, so have 2 factors. We do it again. Move 3 inside here, x cubic, y power 3 times 4, you got 12. And here inside here, -27, right? Z power 9. Right? Yeah. Somewhat complicated, somewhat is not so challenging. Right? Anyone have questions? Anyone have questions? Nope, I didn't hear anyone, huh? So, okay, let's move on. Let's move on. 57. Okay, 57. Okay, 57 actually related to the geometry, right? Okay, let's read here. The square below shown has sides. Each side of the length is this one, right? Okay. Decimeter, this is called decimeters. And you can see that one, find its area, the area. So this side, they have the sides. So this is square. The square equal the side, I'm sorry, let's say area equal the side square, right? Right? Okay, So we can just use right here. So A equal the side. Side is A Z power 5 n square. Just use a knowledge we learned. This is two factors here inside, right? So A square, 84. Z power 5 square. So 2 times 5, right? You got 10. You got 10. Right? That's pretty easy. All right, let's see this one, 58. 58. Given the circle below with the radius 5y. 5y. Actually, here have the unit. You need this decimeter square. Okay, so we didn't write this out. We just write this part. That's 58. The circle below show radius 5y centimeters. Find its area. Area equals what? Pi r square, right? So A equal pi r square. So r equals what? R equal 5y, right? So replace by 5y square. So look at the pi. Here goes 25, right? 25 and y square. We adjust the numbers in front. We say 25 y pi y square. All right, so that's it. So in the geometry, actually with Algebra I, actually we provide a lot of information is prepared for your next year geometry. All right, let's move on. Let's see 59 and 60. Let's see 59. The value below is in the shape of a cube. If each side is right here, each side is the same number, right? So find the volume. So volume equal side cubic. The side actually right here. So we'll replace it, right? So we can use the knowledge, what are we learning? So each of the factor cubic itself, right? 3 cubic y power 4 cubic, right? So you got a 27 here. So y here you got 12, right? Right. All right, let's see the 60. The silo show is in shapes of cylinder. The radius is 4x and the height is 5x cubic. And the volume equals what? Volume equals the base, pi square, actually the bottom of the square, times the height, right? The bottom of this part is pi r square. So volume here equals base. The base is pi r square, the circle area, times the height, right? So you can get, we just replace the radius with what? 4x, right? The height is 5x cubic, right? So we move this one inside first. So pi, here it became 16, right? Each of them square, and then got this one. So we can, the number part, we can do together. 5 times 16, we got 80, right? Pi x, so x squared times x cubic, so x power 5, right? So the answer is this one. Relatively easy, okay? So when you do the geometry, you will have this part. All right, let's move down. Move down more homework. All right, let's see the quantum rule. Quantum rule, we talked about that one, right? So x n divided x m. If they are the same, is minus of the power part. The base keep the same, only this part. Just like I say 2 times 2 times 2, you divide 2. The top is 2 cubic, The bottom is 2 power 1. So actually this one you can see this is a divided 2 equal 4, right? So you can 2 cubic. I mean 2 square, right? 2 cubic divided 2 power 1. So x3 minus 1, you got 2 power 2 square. So basic, this is basic part. All right, so let's see the question here. 61, right? So x, only here x1 here, right? 3 minus 1. So you got a 2 square here. So you can quickly, you don't necessarily write second step, right? You 10 minus 9, you got 1, or you just get a 1. What about this part? So -4, 6 minus 3. So you got a 3. Here you got what? -64, right? Here, what about this one? So -6 square. So you got a 36, right? What about this part? This part right now, before this one, all the base is only 1. Same. What about this part? The base is different. The base is different. So each by itself, right? We can separate. Let's say power 7. We can rewrite this one actually like this, right? It's q power 15. It's the same, right? We can rewrite this one the same, right? So this same part, the base is the same part put together, right? So you can see p power 6, 6 minus 1 here. And this is q, 20 minus 15, 5, right? So this part you can do in your own mind, just like the same base part you put together, right? So you can see here, 16 here, 66 here, x, so you can say x, 8 minus 1, so you got 7. What about a y? 6 minus 5 is 1, so we don't necessarily write out, right? All right, so this part, 67, same. So number part will be easy. We can do that one, right? So it's became here. What about x? X here cross out. They are the same. So left is 1. So x done nothing left behind. What about y? Y. So y here say y power 6 minus 3. So power 3, right? Cubic. All right. That's it. So that's it. Just rewrite here. All right. See 68. 68. So we can do the same, right? Here we factor out. We became 3, right? The top one is 1. So a part, so a power 3. What about b? B, 7 minus 2 here, right? So you got a 5. 5. Quick question. Did you guys learn this at your school already? Did you learn at this?
No.
No, or at least it's new to you, new topic.
This is
Okay. Okay, so this is new to you. Hopefully helps. Hopefully helps. Okay, let's move on. Let's move on to the right part. All right. Okay, so I clean the screen. Right, let's see here. All right, so this is actually use the rule, right? X power 0 equal 1. X, of course, cannot be 0 first. Any number, any base except 0, the powers of 0 equal 1. All right, so keep this in mind. All right, so this part, 7 power 0, 1, right? 23 power 0, 1. X cannot equal 0. This is 1, right? Any number except x equals 0. Here equal 1. What about this one? What about this one? Anyone? This one power 0. The base only this part, right? Not including this part. Be careful about this one. They didn't put the parentheses here. Like this with the parentheses here. So this is the base, right? So without the parentheses here, only this x is base. This is coefficient part, right? This part, just like this is x, only x is the base. So it's -7 x power 0 here equal 1, right? So be careful about this kinds of expression. Same here. This is the coefficient. This is the base. So here is -2 times 1 equal -2. See 75. So this one is 1, right? This one is 1. So you got a 2, right? What about this one? Here, same thing. Negative here, not a -3 power 0. It's -1 times 3 power 0. So here actually is 3 is the base. This is -1 in front. So it's -1, right? Plus here is 1. So equal 0. Be very careful about this full expression. With parentheses, you can see with parentheses, we consider this is the base. This base. This 4 is coefficient of this y. But with parentheses, this whole piece is the base of this exponent. What about this one? This one, -30 is different from this one, right? It's not equal this one. Here, like it's -1 times 3 power 0. This is like this one, right? It's not equal here, all right? Be careful about this part. All right, let's move on. All right, so C77. So let's just like we say here, -1 times 9 squared, right? So it's -81. All right, without put a parenthesis here. So like we put a parenthesis here is -9 times -9. So it became 81, right? By this part. So 1 cubic, 4 cubic. So 4 cubic is 64, right? Actually, so here, if you put this inside like this, right? All right, see 80 here. So we put this inside, each is cubic by itself, right? So here became 8, here became 27. So we put this inside, here became 2. So this is this part square, right? So you can got 81, the bottom part is Q square, R square. All right, same. This one put inside. So inside each of length cubic. The bottom is 3, cubic is 27. Right? Right. 83. 8 square. So this one will be easy. So it became 2 plus 3 plus actually here 1 here, right? So 6. So here has 1 here as well. So the base is the same. Just needed the exponent part. Sum of length, right? So 2 plus 15 plus 1 got 18. All right, so see this part, product. Actually, this one, so you can see actually here is 2 times x cubic, -8 times x power 4. So we coefficient part, product length together, so it became -16, right? X part, x cubic, x power 4, so x power 7. 3 plus 4, you got 7 here. Right? 86. 3 times this part, so coefficient part. So -15. Y here is 4. Here actually have 1 here, right? So 4 plus 1, so got 5. Actually, you can most time, maybe sometime, maybe not easy understanding this part. Just say you can break it down 3 times y power 4 times -5 times y, right? So you can do the commutative kinds of property. You can just bring this in front, negative put it in front. So the rest part here is -15 y power 4, right? So same mechanism. Okay, let me clean the screen, move down a little bit more. Okay, so, all right, let's see 85. 85. So here, this part, coefficient part. So it became -16, right? x power 3 plus 4. So you got 7 here. Oh, we talked this already, right? All right, so 87. So this part actually have two factor here, right? All right, so we use commutative methods. Actually is, you can say A and B actually is this part, right? So you can got A power 11, 7 plus 4 here, B 12 plus 8, you got 12. So actually these two factors as well. All right, so 88. So that would be make it easier, right? So have two same factor, we can put a base part together. Base part. So here is 17, right? J here. J here is 2 plus 13. You got 15. That's too easy for you guys right now, I believe. Let's see this part. So -2, -13. So you got a 26. And here M1, here M8. So go to M9, right? N power 6, N power 1, N power 7. About this one. So here, this part is 21, right? S 5, 1. So you got 6. T here 1, T 10, T power 11. Right? One step. You guys definitely can do that one. What about this one? It's the product rule, right? Product rule is 4 times 10. Z 4 times 10, right? Not 4 plus 10. It's 4 times 10 called product rule. Remember that one. X power n. They have m kinds of x power n together. So it became n times m, right? Remember this rule. So you can got a z here is 40. So here got a j t power 55. What about this one? This one also 93. 93. So this is the base, right? Square. So each of the factor square. -6 becomes 36. X square. Y square. Z power 6, right? So each of the factor cubic. So here became -27. X power 3. Y power 6. A power 9, right? Because of 3 times 3, you got 9, right? All right, this is quantum rule again, come back here. 3, we just keep it, right? X 5 minus 4, so you got a 1. So 1, you don't necessarily write out, right? Yep, so you just 3x, right? All right, 96. Here got a 5, because of the coefficient bottom here is 1, 5 times 1. X 9 minus 3, so you got a 6. 97 square, each of the factor square, right? So 9 square, 81, x square, y square, right? All right, these 3 factors, right? So 2 power 5, 32, right? 2 power 5, 32. A power 5, B power 5. All right, see 99. So this is 2 separately. 2 power 0, we know that one learned just earlier, right? 1, 2 power 5, 32, right? Right? So you got a 33. Same here. Here is the 49. Here is 1, right? So you got 48. Anyone have question about this part before I move on? Any questions? Yeah, we do a lot of practice here, huh? With different situation. All right, so let's move on. Clean the screen. All right, go 101. 101. So this is a factor inside, right? I mean, as a fraction inside is the base. So each of the denominator, numerator, need the power by itself, power cubic. So it became 3y power 5 cubic, and the bottom is x power 4 cubic. Of course, you can make it simplified first actually here. So you can see 3 here became 1, here became 2, right? All right, so you here got y power 15, here became what? It became 8, x power, this is product rule, right? 3 times 4, so you got 12. All right, let's move on. 102. So we factor first. So here became 3. So each of them, each of the numerator and denominator need to be powered by itself. The bottom 8, 3 power 4 equal what? 3 square times 3 square, so you got 81, right? Y power 4, Z power 4. All right, see 103 here not outside, so we can factor them. Factor out, here became 1, right? X here became 2. So you became 2x power 2y, right? All right, so this part and this part. So you can get x power 7, y power 6. That would be easy for everyone, right? This is just quantity rule. All right, let's move on the last part before, oh no, that's 2 sections here. Yes, 2 sections. All right. Let's see 105. Combine like terms. We didn't talk about like terms actually, but this is the very simplified version like terms. We do it before. Actually, we use it all the time. We didn't consider it at those moments. We didn't talk about like terms. All right, but we will talk about today. But here, I think it's very easy for you guys, right? Because we use it all the time for our equation, linear line equation, and linear line inequality kinds of combination. So here, the power here, you can see only 1. So no big challenge for you guys. So let's see here, 105. So here you can got a 2y minus 10, right? You guys can do this one. This y you can combine together. Like this part, negative 6z, negative 3z, so you got a negative 9z plus 20, right? All right, so, and this part, you can see here, they can combine together, right? So you can get a negative x, and the rest is 2 minus 6 equal negative 4, right? Here, this part, 10y minus y, you got a 9y, right? So minus 28. What about this part? So for this one, did you guys do this distributive method first, right? So it became 2x minus 10. What about this part? Negative plus 50 minus 3x. So we can combine this. So it became negative x plus 5. Right? Let's see the 101 here. Distribute inside first. Distribute inside first. Right? Minus 21. Here became 5w plus 5. So equal. So here became 2w, right? So what about this part? Here became negative 16. 2w minus negative 16. All right. Last section. Last section. Check the concept. Try to find out what kinds of operation needed for the calculation. Operation needed to simplify each. All right. So here we know that one is 14 times 12, right? This product rule. Product of multiplied components. Product rule is x. Here is 14 times 23, right? So it's multiply the exponent, right? So what about this one? This one is called this product of these two exponents. So actually this exponent actually just plus together, right? So it is add, then together. So you got to add them. So you can say A, you can put C in front of here. All right, so here we didn't use anything. We didn't use anything. They cannot combine right now, right? And 14, this is quantum rule. So it's subtract, right? Subtract. So you got x power 18. Subtract. Here so is B. Here is none of these. We didn't use the divide exponent yet. We didn't go that part. Divide exponent actually use the square root part. Something x exponent n. So here is n divided n. We didn't go that far yet. We didn't go that far yet. So let's not divide the exponent here. Only use the 4 of them. All right. So homework part is done. Any question about this part? I know this part maybe need some time to digest, but it's very important part. Very important part as well. Okay, so homework part is done. Anyone have questions? No. Anyone have questions? No, no questions? Okay, so let's take a 5 minutes break. Come back at 3:50. 3:50. Sounds good? All right, see you soon.
Teacher.
Yep.
I need to leave for a rehearsal.
Oh, okay. So let me take, I know I have a record video. So if you leave early, definitely you can leave in. I will post the video online. So send it you guys.
Okay.
Ask your parents, ask me, make sure I can send you guys link on time. Sounds good?
Okay.
All right. See you soon.
Bye.
Bye.